So the u substitution doesn't work, which means I have no choice but to cube this. So check your math, see if you were able to multiply it all out yourself. And then I brought the x squared down and I distributed that. And so now I know that all my powers are even, so I know this is an even function. And if you noticed on the last one, by splitting it so that it goes from 0 to the upper bound, that means when I substitute in 0, everything turns into 0, so it's less math when I actually do the calculations. So now that I know it's even, then I can double the integral from 0 to 2, and then I'm ready to power up. So pause the video again, see if you can power it up, and do all the algebra or the simple math magic and get to the actual numerical answer yourself. I actually cheated and I plugged 2 in using my calculator. It was a whole lot easier. Okay, on to the next one. So on this final one, of course I don't have integral for a combo of sine and cosine, so I'm going to have to do some substituting, and I try to figure out, is there anything here that's being raised to a power? And of course the answer is yes, the sine is being raised to a power, so I'm going to let sine be my u, so that when I substitute in, that's a u squared. And then if I take the derivative, of course I get cosine x dx, and oh how fortunate! So I'm going to replace all of that with du. I didn't have to add any extra something. And then I'm going to change the bounds so that they're u bounds, because those are currently x bounds. So if x is equal to pi over 2, then u will be 1, because I would be doing sine of pi over 2. And if x is negative pi over 2, then u will be negative 1, because sine of negative pi over 2 is negative 1. So I would be going from negative 1 to 1. And I notice that this, again, is an even function, since the power is even. So I could just go from 0 to 1 and double it. And of course, powering back up, I get u cubed over 3 from 0 to 1, and then when I plug in 1, I'll get 1/3 for a final answer of 2/3. Pretty simple, huh?